Alright. How are we going? Alright. We've got 3 questions left. So we've got Newton's law of gravitation. So we're now up to gravitational force and field. This is a very large-ish topic. I don't know, actually. I feel like vectors, projectile motion, and inclined planes, they're all kind of grouped in together as one topic. Whereas gravitational force and fields and orbits are kind of grouped together as well. And electrostatics kind of ties into the second topic of Unit 3. So, yeah, anyway, back on topic. But first, I'm going to have some water, because it is a hot day. Alright. So, Newton's law of universal gravitation, and I advise you guys to memorize this if you can, because what QCEA tend to do when they write the exams, especially for physics and chemistry, they like to say, oh, pick the right definition for Newton's law of universal gravitation, or the definition of a vector, or something like that. And the wording might be slightly off. And if you actually look at the syllabus, sometimes they actually provide exact definitions that they want you to remember. So that's why those syllabuses are really important as well. So make sure you're making flashcards or palm cards with these definitions. So the law is every object with mass attracts every other object with mass in the universe with a force called gravity. So, and that is where we use the formula. Force is equal to the universal gravitational constant, which is provided to you in the formula sheet, multiplied by the two masses, so mass 1 and mass 2 of the two objects you're dealing with in the space, divided by the distance between the center of mass squared, and that's measured in meters. So now we're going to get started on this question. So this covers the criteria to solve problems involving the magnitude of gravitational force between two masses. In the past exams I've seen, they tend to have at least one of these in part 2 of the exam. So make sure you know this content pretty well. Alright. I think personally, and I'm just gonna say this, I might be totally different to other people. I found Unit 3 harder than Unit 4 because Unit 4 was a lot of theoretical, whereas Unit 3 is a bit more mathematical. So I found that Unit 3 needed a bit more practice, which is probably why they teach it to you first. So just keep that in mind. I just wanted to say that before I forgot. Calculate the gravitational force the sun exerts on the Earth, given that the radius of the sun is 6.95 by 10 to the 5 kilometers, and its mass is 1.496 by 10 to the 8 kilograms. The radius of the Earth is 6380 kilometers, and the distance between them is 1 astronomical unit. Now, I just want to make a note here. 1 astronomical unit. I have never seen, when I was studying physics at least, I have never seen them use the term astronomical unit. I looked at the formula sheet, couldn't find it for the life of me, so I don't know whether this is something that is now needed to be memorized. Because that's actually something I had to go and Google, an astronomical unit. It's essentially just like 1 light year, I found out. But yeah, anyway, I'll share that with you in a minute. But if you wanted to start putting it into that formula and have a go at it, I advise you drink a bit more water, which is why I say to get started now. But remember your conversions, because these are given to you in kilometers. And you need your distances between the centers of mass to be in meters. And that's something that always trips people up. Alright. So I'm just going to get started. So we've got force is equal to that constant, multiply the first mass by the second mass, big M and little m to distinguish between the both, divided by radius squared. So now we've got our constant, which is equal to 6.67 by 10 to the negative 11. And the computer is going to die. At least it showed me the notification. Had plenty of charge. Had. Keyword had. Yeah, so by 10 to the negative 11. Multiplied by that first mass, which is going to be 1.496 by 10 to the 8. Multiplied by 5.97. Let's make sure we're using the right one too. Yeah, 5.97. By 10 to the 24. Okay. Now, all that's going to be divided by, it's going to be a long division symbol, our radial distance. And we also need to convert this into meters as well, all of this. So first we're going to put it in one big bracket, like that. And then we're going to do another little bracket. I'm going to start writing it in, so 6.95 by 10 to the 5. Where am I at? Plus, because we're going to add these radial distances, 6380. Yeah, so those first two, those are the ones that they give us. The radial distance of the sun, and the radius of the Earth. And now we've got the astronomical unit, which is 1.5 by 10 to the 8. So plus 1.5 by 10 to the 8. By 10 to the 3. And that 10 to the 3 is to go from kilometers to meters. And this is something that a lot of people forget. And then you square all of that. And yes, that is a lot of numbers in one spot. It is a little daunting, but it will be okay, I promise. Now, we chuck that into the calculator, so bear with me while I do that. So 6.67 multiplied by 10 to the negative 11. Brackets are very important in physics. I need to emphasize that as well. The number of mistakes that get made because people don't use brackets is insane. Very important. Okay, I'm up to the denominator now. Alright, we got a number. The force is, and I feel like this is really low now that I look at it. It is a positive number, but I'm just thinking I might just put in a couple more brackets just to be safe. When in doubt, add more brackets until your calculator says no. No, same answer. Okay. 2 point, and hopefully you got the same answer too. 2.62 newtons. That was it. Oh, that's rounded, by the way. So, wavy lines. And yeah, so that's what I ended up with. That is the force. That is the gravitational force that the sun exerts, and I'm pretty sure that is quite low. I'm wondering why. Because it has to be in meters. So it has to be multiplied by 10 to the 3. It could... No, I don't see a mathematical error there, so we're just going to go by that answer. If you have any questions, or you're not so sure, or you all ended up with a completely different answer to me, then please put it into the chat. I'm just looking back and forth here. I feel like that should all be... I feel like I should have ended up with a much bigger answer. Oh well, that's okay. Alright, gravitational force and fields again. So a gravitational field is a mathematical description of the region of space about a massive body, for instance a planet, in which other masses feel a gravitational force. So at any point P in space, as a force of gravity felt per unit mass placed at that point. And this is where we have that formula. Gravity is equal to the force of gravity divided by mass towards the planet's center or down. This formula isn't really used a lot. It's literally just a variation of what we've been using earlier, which is the force due to gravity is equal to the mass times gravity. But yeah. These are probably used a little bit more. So we've already talked about that top one, but it's literally, yeah, it's what we've done already with the formula we just looked at, but instead we've just replaced force with gravity. That's it. But we've also included, I don't know why they've involved D at the bottom if we're not actually using D. They're literally just been about R. This is R. Not to confuse you. This gets provided, once again. Yeah, so this is the gravitational field of the planet, okay?